Okay, so this is the assignment 2 YouTube video. So to start, first we have pip install Talos. Whenever this runs, the code output has this whole thing to show, has this whole long block of output, just to show that it's installing. And then after that, we have import pickle and import all these other things that are needed for it. So step one, we just have to load the data set. We're given two files, a train and a test file. So we just um, open them up in the code using with open, same as we did the last assignment. Next, we have to extract the image data and labels. So we just extract some as X train and Y train, and then we extract some testing data as extract X test and X and Y test. Um, After extracting the data, we can now normalize image data. Um, it's not always required, but it's a lot of, I found that it's a pretty decent recommended step for getting neural networks to work. Um, so first we just do this by saying xtrain equals xtrain divided by 255, and then we do the same for xtest. Um, then we convert the labels to categories. So we just do ytrain and then this, and we do y tests, and then same thing. Finally, step two, we have to define the hyperparameter dictionary. This code was given to us by the assignment, um, or by the tutorial. Oh, there you go. So finally, next we move on to step three, where we just define the model function for Talos. So we just define ci cifar underscore model, x train, y train, x val, y val, and other parameters. So we have the sequential model to already input it. We did not have, in the tutorial, they had to flatten it. In this tutorial, we did not have to flatten the model. So we don't need that step. Um, so after that, we have our input layer. And then we have step four was to add 5 hidden layers. So I just did that with for loop and the for loop in the same command to the input layer. And we used basically unit. I did not have the input shape on this one. Um, that's because this is the input model. So after adding the 5 layers, we move on to step 6, where it's just we have an output layer with 100 units and a chosen activation function. So I just set the activation function as activate and then had 100 units set. Finally, we are able to compile the model with the um, so we just basically do model.compile optimizer equals parameters or params optimizer, and then loss parameters with loss, and then metrics equals accuracy. Finally, step 7, we get to train the model, and we train for 200 epochs. So we just do that by saying out equals model.fit, open parentheses, xtrain, ytrain, validation date data equals xval and yval, batch size equals parameters, or batch size, and set the epochs equal to 200 and for both set equal to 0. And then we return our model. Um, and then this was step 8, which I believe was in optional extra credit step that we could do that wasn't necessarily required. But after running the code, as you can see, it I'm not going to run it in the video because it normally takes a long while. Like, um, I think this one took about, yeah, 43 minutes just to run and finish running. But as you can see, the accuracy of the model is 62%. So that concludes the video for this assignment.